You know, we use the internet every single day, but have you ever really stopped to think about the massive, invisible engine that's powering every single click and every tap? Well, we're going to go under the hood and see how it all actually works. Think about it, right? It's something you probably do dozens, maybe hundreds of times a day. You type in a web address, you hit enter, and poof, a website just appears. It feels totally instant, almost like magic. But what's really happening in that tiny fraction of a second is this beautifully coordinated dance across the entire globe. So let's break that down. Okay, so to really understand this journey, we're going to start with the most common thing we all do online, just browsing the web. I want you to imagine for a second that the entire internet is this one colossal library, and you're standing right in the middle of it, looking for one specific book. So you know the title of the book you want. Let's say it's CompTIA.org, but you have absolutely no idea where to find it in these endless aisles. Well, your browser, it's facing the exact same problem. It knows the name of the website, but it needs to find its actual location on the internet before it can go and grab that page for you. So how does it find the address? Well, it asks the Internet's Master Librarian, the DNS, which stands for Domain Name System. Just think of it as the Internet's giant universal address book. Its only job is to take that human-friendly name we type in, like CompTIA.org, and translate it into a computer-friendly IP address, which is kind of like the server's actual street address on the network. And this whole process unfolds in 4 lightning-fast steps. 1, you type the URL. 2, DNS does its thing and looks up the IP address. 3, your browser shoots off a request to that specific address. And finally, 4, the web server responds, sending all the website's content right back to your screen. It's this perfect little sequence, and it all happens in the blink of an eye. When you get right down to it, this is all just a simple conversation. Your computer, which in tech speak we call the client, sends out a request. That request travels across the internet to the correct server. And then the server sends back all the building blocks of the website, like the code and the images. It's just a constant, really elegant back and forth. But that brings up a really important question, doesn't it? If your computer is having a conversation with a server out there, can anyone else listen in? Well, it turns out that depends entirely on what kind of connection you're using. The easiest way to think about it is with a simple analogy. A standard HTTP connection, that's like sending a postcard. Anyone who gets their hands on it along the way can read the entire message. But HTTPS, now that is like a sealed, tamper-proof envelope. It encrypts the whole conversation, making it secure. That's why you always want to look for that little S and the lock icon in your browser before you type in any passwords or credit card numbers. It's your sign that the conversation is private. All right, so that's web browsing. Now let's switch gears and look at another thing we do all the time, sending an email. The process is kind of similar, but it uses its own special set of invisible services. This time, think of it as the internet's digital post office. The second you hit send on an email, you're basically handing it off to the SMTP. That's the Simple Mail Transfer Protocol. Its one and only job is to be the digital mail carrier. It takes your email from your computer, gets it to your mail server, and then that server uses SMTP again to pass it along across the internet until it reaches the recipient's mail server. So you gotta remember, SMTP's job is to push the email out from your laptop to the server and from that server to the next. But, and this is the key part, to actually read your email, your device has to use a completely different protocol, something like IMAP to pull the messages down from the server. So you've got one service for sending and a totally separate one for receiving. And that actually brings us to an important choice. Once that email is sitting on the server, just waiting for you, how do you want to access it? Historically, there have really been 2 main ways to do this. So the old school way was this thing called POP3. It's like going to the post office, taking all your mail home with you, and the post office doesn't keep any copies. It basically ties all your email to one single machine. But the modern way, the one we mostly use now, is IMAP. IMAP leaves all the mail on the server and just syncs it across all your devices. Read an email on your phone? Bam, it's already marked as read on your laptop. It's a simple idea, but it's the brilliant engine that makes our modern multi-device lives possible. All right, for this last section, let's do a little lightning round. We're going to meet the rest of the backstage crew, all those other protocols that handle the essential jobs, everything from working remotely to transferring files. So picture this. You've got a single server, and it's trying to handle website traffic, email, and maybe even file transfers, all at the same time. How in the world does it keep from getting totally confused? How does a request for a web page not end up in the email department by mistake? Well, the answer is actually surprisingly simple and pretty clever. Port numbers. If a server's IP address is the street address for a huge office building, then the port number is the specific door for each department inside. Web traffic knows to go to doors 80 and 443. Outgoing email goes to door 25. Every type of traffic has its own dedicated entrance, which guarantees that every request gets routed to the exact right service that knows how to handle it.
Okay, so how do people actually manage all these servers without being in the same room? Well, they use a remote maintenance crew. You've got SSH, which lets an administrator securely type commands on a server from halfway around the world. It's like a secure text-based remote control. And then RDP takes it a step further, giving them full visual control of a remote computer's screen just like they were sitting right in front of it.
And finally, we've got the services that just move our digital documents around. FTP is kind of the original workhorse for transferring files. And SMB, that's the secret sauce that lets you seamlessly access a shared folder or a printer on your office network. They really are the unsung couriers and copy centers of our digital world.
So, there you have it. When you put it all together, DNS, HTTPS, SMTP, IMAP, and all these other backstage protocols, they make up this invisible, tireless engine that works around the clock in perfect coordination just to deliver the digital experience we all rely on every day.
It really is a beautifully coordinated dance, isn't it? From DNS to SMTP to HTTPS, every single time you click, you're kicking off this unbelievably complex sequence, a conversation that spans the globe faster than we can even perceive it. And all of this leaves us with a pretty fascinating question to think about. See, these protocols were designed for a world of desktops and servers. But as we start connecting everything, from our cars to our coffee makers to the internet, what new invisible engines are going to be needed to power the next generation? That's the future that's taking shape right now, just behind the screen. Thanks for exploring it with me.